So last day, we started talking about multiplying fractions. And of all the different math operations that exist with fractions, adding, subtracting, multiplying, dividing, multiplying is probably going to be the most important. So I'm going to teach you strategies today that get used later on in Math 9, Math 10, Math 11. So there's more than one way to do questions. There is a standard grade 8 way and a different way which I'm going to show you. Yes, Clay?
Do we need English to pass grade 12?
Yes, you do.
And then is math grade 11?
Math, you need all the way up to grade 11. So,
I can quit that in grade 12?
let's talk about fractions. So on to the second page. So what we talked about last day is when we are multiplying fractions, to get our answer, we multiply the numerators together, the top numbers together. 3 times 8 is 24.
6.
And multiply the denominators together, the bottom, to get the bottom number. What's 4 times 9?
25.
Nope, not 25.
What are you?
I heard somebody back there say it.
36.
36, thank you. We get our answer and then we try to simplify it. And you go, hey, is there numbers that can fit into the top and bottom to make it smaller? Right? What can you divide?
6.
6 works, right? So 6 can fit into the top. So we go a little divide by 6 here and divide by 6. And you go 6 fits into 24 4 times and 6 fits into 36 6 times.
Can you make it littler?
And you can make it smaller. And you go, because sometimes when you divide, it may take more than one step. So you go, okay, there's still even numbers, so we can divide by 2 and make it a little bit smaller.
And then you can divide by
1. By dividing by 1 does not change the numbers. So that is the most simplified you can get. So now, when I'm marking these, everybody in this class can get at least 50% coming up in the quiz next day. Because all these questions will be worth 2 marks. 1 mark is just coming up with this answer here. Just multiplying the tops and multiplying the bottoms together. The rest of the marks come from getting to the final answer. 2 marks here. So if you can make it all the way to the smallest form, you get 2 out of 2. And maybe you didn't make it all the way to the smallest form, you made it smaller, and you get like 1.5 out of 2 for doing that. Okay? So that's how the marking works. Now, there were some tricky questions last day, right? And it had questions like, let's see, 4 times 3 over 2, where one of the numbers didn't have a numerator and a denominator. And I said, hey, that 4 actually does have a denominator. It's an invisible 1, because 4 is the same thing saying 4 out of 1. So if it helps, you can draw the little 1. All right? And we multiply the tops together. 4 times 3 is 12. And 1 times 2 is 2. And you try to make it smaller. Right? How can you make this smaller? What do we do?
You can divide it by 1.
Well, dividing by 1 doesn't change it. Divide by 2.
Okay.
Divide by 2. And you get 6 over 1, which is, so that just means it's 6. Okay? Now, this is how most grade 8 teachers teach it. And if you're comfortable with this, I think this is probably the most straightforward route. You're welcome to do it. But that's not the method I'm going to teach from this point forward. I'm going to teach you a different method. This method going forward is what we're going to use in high school. And lots of different kinds of math. So I would really, really like it if you can make it, the next one work. The next one method is a bit more randomness. So it's not as straightforward. Some people can have a little bit more difficulty. Now, so the way we multiply is we multiply the tops together, we multiply the bottoms together, we get our answer, and we try to make it smaller. What the issue with this method is, sometimes when you multiply things, you get really big numbers. then it becomes a lot of effort to make it small. And trying to get it to the smallest state possible becomes sometimes very hard to do. So there is another technique. The other technique is, hey, before we multiply, we're going to try to make the fraction smaller. Right? So instead of simplifying at the end, we're going to do that at the beginning.
Jim, what was that?
Shh. So we look at when we simplify, we divide top and bottom, right? And we try to make it smaller. So I'm going to draw a little picture of fractions here. So these are little brackets with fractions in it. We look at the top and the bottom. We go, hey, what can I divide here and make it smaller? What can I divide here and make it smaller? So I look at this 3 and this 4 like this. And you go, is there any number that can fit into 3 and 4 to make it smaller? No. So we leave that fraction alone. Then we look at 8 and 9. Is there anything that can fit in here to make it smaller? No, nothing. Right? So we try to make our fraction smaller this way and this way if possible. But we also look at a diagonal. Because we compare tops to bottoms. So we compare the 3 versus 9. Can we make this smaller in this direction?
Yeah.
What can we divide by? 3. So now instead of writing down divide by 3 like we did over here, it gets too messy. There's too many numbers. So what we do is we cancel numbers off as pairs. We cancel this pair with this pair. Right? And we're going to divide each one of these by 3. And you go, okay, 3 divided by 3 is 1. And you just write your answer on top. And you go to the bottom one. You go, 3 fits into 9 3 times. And you write it like that. Okay? You cancel it off with a pair, right? Any top bottom pair. So we go this way. And we check the other direction as well. We go 8 and 4. Is there anything that can fit into 8 and 4? 4. And we cancel off those as pairs. Pair, pair, canceled off. And you divide each one of these by 4. You go 4 fits into 4 once. And 4 fits into 8 twice. Okay? So now,
Then equals 3.
it does not, well, we're not done yet. All right? So now we make these numbers as small as they could be. And you go, okay, we're working backwards. Now we multiply the tops together. 1 times 2 is 2. 1 times 3 is 3. Still the same answer as before, but a different approach.
Could we use the other way?
You can use the other way. Now, this method really has strengths when the numbers get bigger in other areas of math. So I would like you to practice it, but if it's like really confusing for you, you can always do the other way. This is the preferred method, okay? So, but we're going to do this for the next 4 lessons. The next 4 lessons all have multiplying in it. So you will hopefully, by the end of the 4 lessons, you'll get really, really good at it. So that's how we're going to proceed, right? So we need to compare all tops and bottoms, right? So we're going to say, compare all tops and bottoms. Okay? Now, where students go wrong with this method is 2 spots. Is sometimes they pick 2 top numbers to make it go smaller, or 2 bottom numbers to make it go smaller. It doesn't work that way. When you're making a fraction smaller, it has to be a top-bottom pair. Okay? And the other thing that maybe students will lose some marks on is when they do that correctly, but they come up with their answer here, but their answer here may not be the smallest answer possible. Because when they're crossing things off with a fraction, they didn't see something and they missed something. Okay? So when you do it this method, you still need to look at your final answer. You go, hey, can I make this fraction any smaller? Because maybe I missed something before. Because you always need to do that check at the end. Right? So we're going to do a few of these to practice. We're not going to do all of these. This is a lot. Right? So Let's look at, oh, that one we already did. Let's look at B here. All right, compare tops and bottoms. And go through a little method. The first fraction, can you make that any smaller? 1 and 2?
No.
No. Second fraction, can you make that any smaller? 4 and 5?
No.
No. Okay, check the diagonals. 1 and 5, can you make that smaller?
No.
No. 4 and 2, can you make that smaller?
Yes.
Yes, by dividing by what number?
2.
2. So we cross them off as a pair. Then we do our calculation. 2 fits into 4 twice. So you put a little 2 up there. 2 fits into 2 once. Right?
So then 3.
So not 3. We're multiplying at the end. We're not adding. 1 times 2, 2. 1 times 5 is 5. 2 over 5.
What?
Huh?
That no
That
makes
works.
sense, Jason.
Yeah, what part don't you understand?
I don't.
Alright?
I don't know. Okay, I'll figure it out.
I'll talk to you afterwards. We're working our assignment.
Okay.
Okay, let's do a couple more here. Let's do the one right underneath here. D. Alright? So you don't have to go in the order of first fraction, second fraction, then check the diagonals. That's a nice systematic way. But if you see a pair, top and bottom, to make it go smaller, you can start with that. Do you see any top bottom pairs here that you can make smaller?
No.
Alright? Jay says no. Anybody else see anything on this one? Alright?
It's still
There is some.
Yes, there is some.
Brady, what do you see? 21 and 7. What number can they be both divided by?
3.
7. Right? So this method, if you're really good at your multiplication, you see the answers right away. If you're not good with your multiplication, this method takes a little bit more effort. So you divide each one of these by 7. 21 divided by 7, we get a 3. 7 divided by 7, we get a 1. Okay?
And then you can do 2
Yeah,
and 5.
2 and 5.
2 and 10.
2 and 10.
And then you
And we're dividing them by
2.
2. And we have 2 fits into 10 5 times. And 2 fits into 2 once. Right? So make sure you have numbers here. Right? And to get those numbers, we're dividing. Right? Ashima.
I was about to do that.
Okay. So now we multiply the tops together. 1 times 1 is 1. 5 times 3 is 15. Right? And we're done. We checked to make it go smaller, but we can't make 1 any smaller. Let's,
Work on your son.
yeah, we'll get there. Hold on. Let's do H. All right. Now, there is no one right way. You're picking pairs. You may see one pair before I see a pair, right? But if you keep on working with all your pairs, you will end up with the same answer. So looking at this, do you see any top-bottom pairs? Yes.
I see 16 and 20.
16 and 20. What could they be both divided by?
4.
4. All right. So we can go 16 and 20. We're going to divide both, cross them off as a pair, divide them by 4. 4 fits into 16 4 times, and 4 fits into 20 5 times. Okay. Yes, Jace.
I see another one, 30 and 5.
30 and 5. Which 5? The black 5 or blue 5?
Black 5.
It doesn't matter.
Doesn't matter.
Just pick one, right? So if you want to do the black one, you can do the black one. But any top, any bottom, right? So you guys said black, so we'll do the black one. So 5 fits into 5 once, 5 fits into 30 6 times. Okay. Any other pairs? Right? Brady?
4 and 6.
Those don't work. Why don't they work?
Because they're both bottoms.
They're both bottoms, right? Has to be a top-bottom pair. Yes?
1 and 6.
1 and 6?
Wait, no.
Nope, 1 can't go any smaller. As small as you can get with the 1, right? That's it. There's nothing else, right? So multiply the tops together. 1 times 5 is 5. 4 times 6 is 24. Okay. I think you're getting there. It's a slow process. All right, let's do G. Then we'll do one word problem. We'll do the rest of the time for it. We'll finish that. Okay. Any pairs of numbers that you see that you can make smaller? Henry.
16 and 24.
Can be divided by what number?
8.
8. Now, when you're trying to figure out what number to divide by, you want to go for the biggest one possible. Okay? It makes the number smaller. But let's suppose that Henry didn't see 8. 8's the biggest one that can fit in here. Let's suppose that Henry saw 4. Right? So I'm going to do it with 4. Right? So I'm going to show you what happens. So you're gonna, he thought, oh, maybe he thought that only 4 can fit into it. So 4 fits into 16 4 times, and 4 fits into 24 6 times.
You can put 8 in there too.
8 would work as well.
Yeah, but he wants to show this for a reason.
All right. So now, the numbers that we have sitting there
It's also dividable.
also divisible. You can reuse it. This is not necessarily our final number. You go, hey, I see another top-bottom pair I can make smaller.
Divide by 2.
You can divide by 2. So it's very common not to see the biggest one. But you can always go, okay, I can cross these off as a pair. I can make them smaller because they're both even numbers. Divide by 2. 2 fits into 2. 2 fits into 4 2 times. And 2 fits into 6 3 times. All right? All right. Is there any other pairs, right?
No.
No. 17 is a prime number. 23 is a prime number. So the only thing that can fit into 17 and 23 are those numbers itself.
So you do 2 and 3?
So no, we multiply the tops together. We go 2 times 23,
46.
which is 46. We go 17 times 3
41.
is not 41.
Oh, it is.
Close. 51.
Oh.
All right? 51. All right? And we can look at it, and that's our most simplified answer.
That's what you can do.
All right? So let's do one word problem. All right. So suppose we have a recipe to make, what are we making here? I think cookies or something like that. And the recipe says, hey, we need to use 4/5 of a cup of sugar for this recipe to make the batch. But then it goes, hey, instead of making a whole bunch of batch of cookies, it's too many cookies, we're going to make a smaller batch. We only want to make 3/4 of the recipe. So if we make a smaller batch, how much sugar would we need to use? Obviously less than 4/5. Yes?
I think it's 3, 5.
How did you come up with the number?
Oh, I'm just multiplying from 4 over 5 to 3 over 4.
Okay, good. Now, let's translate some words, right? Three-quarters, all right? The word of in math world changes the word times. Like add and sum are mean the same thing. Product and multiply means the same thing. Quotient and divide mean the same thing. The word of, you see in a word problem, means times. So this means 3/4 times your recipe. Recipe, all right? So how much sugar is your recipe calling for? 4/5. All right, so you go 3/4 times 4/5. All right, now you could just multiply the tops together, multiply the bottoms together, get your answer, then simplify. Or you can look at this, and do you see any top bottom pairs to make it go smaller? Ashima,
The 4s.
right? Now, if you see the exact same number on the top and bottom, those are easy things that cancel. 4 divided by 4 is 1. Okay. Yeah.
You can, but once you have the 2's, you can also divide the 2's by 2.
There is no 2's. We're dividing by 4.
Oh.
Right? So we're going in one step. Right? So multiply the tops together, multiply the bottoms together, 3 over 5. Right? So we can say we will need 3/5 of a cup of sugar. Okay? And that is it for today.